Hello guys. Today we are going to be talking about uh, considering next technique of calculus of circuits called as or famous as mesh closed loop analysis, and if another understanding way as second Kirchhoff law and or Kirchhoff voltage law technique for closed loop of any circuit. An example, as we see, this picture uh, contains circuit with two loops, two closed loops. Uh, First closed loop is considers two electromotive sources, and second loop considers similar two electromotive sources and some resistances as three resistances as first loop. That second loop considers three resistances too. And if we take direct any arbitrary direct, we choose a long loop, for example, for first loop clockwise targeting, arbitrary, I repeat. And if our current which we have chosen as an arbitrary, similar as target, if they matches, uh, I repeat, target and our current, we take our terms is in our equations with sign plus. Okay, and next type we will write our equations as system. Write bracket and equations for first loop as beginning. Take the current I11 multiply by resistances. Target this current is matches our direction clockwise, and we all these multipliers take with sign plus, and resistances we write as R1 plus R2. It first term, left side our equation plus this current in this branch between two knots, between both knots, we like consider as difference between currents I11 minus current I22, and here we have resistance R5, and our equation almost ready. Equals direction of our sources is matches with our clockwise target 2, and we have wrote as term as right side of our equation with sign plus. E1 plus E2. E2. Okay, first equation is ready, and for second equation we apply similar technique as first equation and will write similar for resistance of loop. As we know, Kirchhoff law for voltages, we should add differences of potential, add one to another. Difference for closed loop for R5, next for R third, next R resistance fourth, and rising voltages for electromotive sources as right side of our equation. And we should for R5 take difference between two currents, I11 and I22. I22 with plus sign, we take I22 minus because it matches with direction, and minus I11 because it towards our direction. Next multiplier R5, as we see R5, and plus next term of left side of our equation is current I second. This these resistances we take as terms with plus sign, R3 plus R4, and we get left side we got side of our equation. Here is attention, our sources electromotive force both counterclockwise and counter our towards our direction, which we choose arbitrarily, and word counterclockwise we take for right side of second equation terms with minus E5 or E4 without difference, and E5 for our right side of our equation. And next transmutes for we get, and after transmutes we have gotten I11 and I1 first term with I11, it will resistance with resistances IR1 plus R2. Here I11 with plus, therefore R5 we take with sign plus, similar. And next term of our equation, left side, we can get as I22 and multiply minus R5 and equals E1 plus E2. We now write as E11 term. Okay, second equation for similar I1 1, we can get minus R5 and next term plus I22 R3 plus R4 and here plus R5, and our matrices for our equation system we in first we have got linear algebra matrix with matrix is square matrix for our equation, and here we write E22 and we get matrix. We can get matrix equations for our calculation of our circuit in the picture. This matrix is, we can in the beginning we write as system of equations as I11 R11 plus I22 R2 I11 R as coefficient in matrix 1 2 plus I 2 R. Okay, here we should 1 put R22 equals E 1 1 and E 2 2. Okay, and we have gotten the matrix R multiply 1 matrix equation equals E, and as we know from linear algebra, solution of this equation find with form I equals R minus 1 multiply E, and for our matrix we can get one divide determinant our matrix from coefficients of resistances of our loops technique and their matrix, their coefficients, which we can write as multiplying inverse determinant for inverse matrix, as we know from linear algebra, A1 1, A algebraic additions A1 2 for columns of this matrix gotten from resistance, have gotten from resistance. It says A 2 1 A 2 2. Okay, short matrix and multiply it by I1 1 I 2 2 2 I say, and matrix, and equals, no, yeah, for yeah, here for yeah. I confused, sorry for my error. And got current. I if which we find currents, current matrix, currents will get currents from matrix current. Okay, equals two equations E 1 multiplied G as conduction coefficient, conductance is conductance like this addition 1 our electromotive sources voltages for or electromotive sources strange differences between potential of electric field strengths as without difference plus E 2 G 1 2 and it equals first current for first loop 1 and similar next equation are similar, and we have our system for any circuit with any quantity of loops, closed loops. We can generate these our calculations as current, any current from any loops current on example G equals algebraic sum from 1 from E I equals 1 from n quantities of our loops and our currents. E EII multiplied G I. Okay, I think I wrote. Our calculations are ready and general system are found and general equations are found too, because therefore if you misunderstood something, write in the comments below, and if you have any questions for me, write in the comments too. And now I bye with you. Goodbye for next lesson.